Hello everybody. In this video, we'll present the major improvements for STRAP 2019. The submodel drop-down menu was pinned to the bottom of the right side menu. AutoStrap program can be accessed from within STRAP. Under Utilities, select AutoStrap. AutoStrap software is opened and the user may start a new project. When running AutoStrap with this option, the project folder of the generated STRAP model is STRAP's working directory. At the end of the process, STRAP program will present the model automatically. When saving a drawing to EDDraw, two options are available. Open drawing after creation and unify collinear lines when creating a DXF file. Under Setup Colors, there's an option to define different colors for positive reactions and negative reactions. Local Axis Display was revised. When selecting wall elements by limiting selection by section, selection options have been added. Select All, select None, or invert selection. The toolbars have been redesigned. An additional icon for displaying rigid links was added. Another useful icon that was added is Move Window Center. This option allows the user to locate by a number a specific node, beam, element, or wall. Multiple views can be deleted. Under Zoom, View List Management, delete saved views, selecting multiple views by pressing the Control key. Doubly wall definition check is added to the option Check Elements Definition. In this example, we can see that walls 6 and 127 are doubly defined. We can use the option Move Window Center and locate wall 127. A new option allows the user to define a moment design unit for multiple wall sections. Under Wall Section, modify for several sections, Design Unit. Select the wall sections and select to make moment design unit for the entire wall or by each shear design unit. Additionally, Walls Design Unit table is available under Output. The thickness of several wall segments can be revised. In the Wall Section window, select Thickness, set the new thickness, and select the segments individually by window or all segments. Element Properties display options now include an option to display properties, number, or element thickness within a contour line. In this example, we can see properties 12 and 13. Under Properties Display option, check Display once per region. We can see the same display option for elements thickness. Solid sections that were created with Crosshack software can be imported to STRAP easily. We can see in the following example a model of a bridge. The bridge's superstructure was modeled with a beam element with property number 12. When we select to define property 12, we'll select the option More. The button From Library will present all the sections available from within a Crosshack file. The user may select a different Crosshack file by selecting Change Library File. We will select the section Rib2. Set the material and section orientation. We can see the section in render view. A new graphic results display is available. On a selected plane, STRAP will show the axial, moment, and the shear force of walls and columns. We selected the submodel instance name import1 #5. Under display type, select the option column wall result at each level. We can see the maximum result, or we can see the results for column and walls above the plane, or the results for columns and walls below the plane. We will display the axial force and moment. Additionally, the user may display the shear results, or all results, including axial force, moment, and shear. When displaying element results along a line, there's an option to define and delete multiple lines within one command. Once the plane is selected, several lines can be defined. And when selecting to delete a line, multiple lines can be selected. When displaying node reactions by table, at the end of the table the program will display the max reaction, and underneath the max reaction on the opposite direction. In the following example, the max reaction at x1 direction is minus 28.8 tons from combination 16, and 24.4 tons is the max opposite reaction from combination number 4. For the x3 direction, all results are at the same direction, so the program displays only one value. In Steel Processor, a new option for intermediate support is introduced. Under Supports, Intermediate supports by spacing. For this example, we'll choose to define the support for buckling around the minor axis direction. Set the spacing between the supports, and set the distance from beam start. In this example, we will assign support definition to a combined beam. So we need to select only one beam member from the combined beam, and the support definition is assigned to the full length of the combined beam. The major improvement for concrete post-processor is the options to check existing structures. In the following example, we can see a model of an existing structure. We can see one of the slabs and the beams at the slab level. We will focus on beam number 5. Specify bars will allow the user to specify the reinforcement for beams. The user must define the reinforcement in 3 locations: support at span start, support at span end, and span middle. For this example, we'll set the following reinforcement. Additionally, the link's diameter and spacing must be set. Under data tables, we can display specify table. Now we can compute. In the results summary, we can see the analysis results under moments. We can see the reinforcement area we defined. Another line of capacity was added. Under moments, we can see the moment capacity based on the specified reinforcement. And under reinforcement, we can see the capacity divided by actual in percentage. Results above 100% will be colored in red. Under shear reinforcement, we can see the link's diameter and spacing we specified. At the capacity line, we can see the analysis results shear force at beam ends 3.42 and 4.63. To the right, we can see the shear force capacity based on the specified reinforcement. The capacity can also be displayed on the screen. Under Data Display, we'll set the capacity parameters first. The user may ask to display the moment or shear capacity and the location. In the detailed results, we can see 3 lines. Moment displays the moment analysis results. Ultimate, the maximum moment that can act on the beam based on the design code and the specified reinforcement. And capacity, moment divided by ultimate. Same 3 lines we can see for the bottom part of the beam. For shear, we can see the ultimate shear stress, and capacity will display the analysis shear force divided by the ultimate shear stress. Let's look at specify reinforcement for columns. Select columns from the main menu and display the main model. We will focus on column 28. Specify bars will allow us to specify the column's reinforcement. Select diameter and number of bars. We'll leave the default division of bars by the program, and additionally we'll define the link's diameter and spacing. After the definition, select a column to assign the specification. From the results summary, we can see that member 28 of column 28 has a specified reinforcement. The capacity of the member is smaller than 1, which means that the existing column design is not suitable to the analysis results. Under detailed results, we can also see the specified reinforcement and the capacity factor. For shear, we can see the specified reinforcement. At the table from the right, we can see the results for shear in two directions. Comb displays the selected combination for design. VD max is the maximum shear force from the analysis. VRDC is the concrete shear capacity, and VRDS is the reinforced section capacity. We can also display the capacity on the screen for columns. Set the capacity parameter, moment or shear, and select demand divided by capacity or capacity divided by demand. Now, let's look into specify reinforcement for walls. Select walls from the main menu. We will focus on wall number 4, design unit A. Selection of specify bars will allow us to specify reinforcement for each wall segment, the concentrated reinforcement and the distributed reinforcement. We'll first set the concentrated reinforcement, and then the distributed reinforcement. Select wall segments to assign the specifications and compute. In the results summary, we can see the specified reinforcement for the concentrated and the distributed. We can also see that the capacity is smaller than 1. In the detailed results, we can see the specified reinforcement graphically. Additionally, we can see the shear results for each shear design unit. Under V, we see the shear force from the analysis, and under allowable, we can see the max shear force capacity. The wall's capacity can also be displayed graphically. In addition to reinforcement specification, certain parameters were added to concrete post-processor to allow the user to check existing structure by code demands. In the default settings for beams, columns, and walls, under reinforcement, the user may set a factor that will divide the material strength for concrete and reinforcing steel. This factor should be set according to the design code. Under shear torsion, the shear strength can also be divided by a factor. Both of these parameters can also be set for individual structural elements under parameters. The number of link legs for a beam can now be set by the user. 3 options are available: user-defined, the maximum allowed by the code, or max spacing. This setting can also be set for individual beams under parameters. There's a new option to draw vertical reinforcement of columns and walls on a plane. Define a new drawing. Under Add General Arrangement Drawings, 2 new options are available: vertical bars for walls and vertical bars for columns. You can select the slab by selecting a beam or selecting an element. We can see the general arrangement drawing with the vertical reinforcement of the walls and the columns. Now, we'll demonstrate a new option in EDDRAW. Print a drawing to EDDRAW. Under Line, a new option to define or move dimension line is available. We'll define a horizontal dimension line. That's it for this video. Thank you very much for watching.